Continue. Okay, where is it? First thing first, I think I want to handle this integer overflow. So, where is it? I think this one. Oh, right. Previously, I kind of confused, right? Where do we save the symbol during the runtime? And it seems like we allocate new memory for the symbol. So there is that. Let me put this in the chat. In case anyone wants to take a look too. Maybe I will use this one. You know, because it looks like this function evaluates the type. I mean, size T can be different between machines. And let's try that out first. Let me remove that. Size T. What is it called again? Let's call it result. Okay. Let me compile this. Okay. Looks like we can compile that. The return type for string line is size T. So let's flow per flow. besar. Oke. And then unlink stick on one. Oh. Wait, maybe I should do this. Size T max. Let's say 1, right? Overflow indicator. And then result. Overflow indicator. And then result. Maybe something like this. Wait, not that one. Does not have pointer to. Oh, okay, this would be like this. Now let's change max to have unsigned long. So basically we are trying to add the maximum of size T in 64-bit, if I understand correctly. We are trying to add the maximum value with 1 in here. So it's like U long max plus 1, something like this. Let's check that out. Okay, so we are overflow. Result is 0. Alright. But the interesting part is that if we do this, right, the max in here already overflow. And guess what? If the, what is it called? If the the variable at the overflow, or the value at the overflow, the built-in function overflow checker, like this one, will not detect the overflow. So we must make sure that the argument did not overflow. Okay. Alright. But yeah, make sure that string length is not overflow. Anyway, remove that. Unlock size, and then unsigned in. Okay. Flow indicator. I think this was fine. Put not zero. One unlock size, and then unlock size. If overflow indicator, it means if the overflow indicator non-zero, not this one. We need to throw an error, something like this. Alright. sign in, overflow indicator, okay. Of course, I need to change this. Right, unlock size. Right, we need to put that in here. Unlock size. Maybe okay. Here, so I like put every character declaration at the top, something like this. Let me think. Maybe let's put this in here. Then this one too. Okay. Because there's a possibility that we might need to unlock it. The symbol into a new memory location. Yeah. maybe something like this. Now let me... Okay. Read declaration. Alright. Then what about this one? Okay. Alright. Cannot forget about that. We copy the value. Yeah, my concern is still this. I mean, if we hit or we call the MPC AST delete, right? The symbol that we are creating might get deleted and become dangling pointer. So the memory address already been free. Well, let's commit the previous one first. Oh, I didn't put this in here. Okay. I mean, should I put this at the top too? Like all the declaration at the beginning of the function, something like that. timeline. Well, let's put it like this for now, I guess. But yeah, I'm kind of curious. Have a copy and in env boot. Make sure the okay, like this. Variable. Here to find. Yeah, this make me kind of curious though. Let's take a look at GTP. Okay, So what is it called? We declare the variable first, maybe something like that, right? Yeah, this is something gibberish, I guess. So maybe I should put that in here. I mean, if every declaration at the top of the function, that should make finding the declaration easier, right? Or maybe length file name and temp length. Okay. Alpha copy. How many alpha copy we have? Okay. When in the get. Okay. Put. Well, anyway, let's continue first into the chapter 11, or maybe this one. Defining the function. We've managed to initialize our built-in as variable, but we still don't have a way for the users to define their own variable or symbol. This is actually a bit awkward. We need to get the user to pass in a symbol to name as well as the value to assign to it. But symbols can appear on their own, otherwise the evaluation function will attempt to retrieve a value for them from the environment. The only way we can pass around symbols without them being evaluated is to put them between curly brackets. In a quote expression, right? This is, what is it called? The symbol for quote expression instead of the single quote, like in the common Lisp, I guess. So yeah, this is the, what is it called? The difference between this book syntax, this book Lisp syntax, and the common Lisp one. So we are going to use this technique for our definition function. It will take as input a list of symbols and a number of other values. Okay. A list of symbols and number of other values. It will then assign each of the values to each of the symbols. This function should act like any other built-in. It first checks for error condition and then performs some comment and returns a value. In this case, it first checks that the input argument are the correct one. It then iterates over each symbol, and value, and puts them into the environment. If there is an error, we can return it, but on success, we will return the empty expression. Let me instead, when overflow happen in before that overflow value instead of most likely result in false positive. Is that the word? False positive, no, not. Give out no overflow indicator. False. Most likely result false. Okay, alright. Hello, yes, welcome. Okay, I'm currently on the chapter 11 of the book, trying to implement an environment for the variable to store a variable, or maybe a symbol in this case. So yeah, let's see how it goes. Built-in def. Let me put this in here. Built-in def. Maybe I will put that. Okay, alpha. Built-in def. Like this. Did you use the environment? Okay, yes, we used that. Alright. Start alpha. Built-in def. Start lnv. Value. if the type is quote expression or not. If it is not quote expression, we throw this error message. Okay. If value cell cell is pointer of pointer, and then type right not equal. Okay, this might be confusing for someone who just joined. If I take a look, where is it? This one. So the condition or the second parameter is actually the negation of this condition. So if this is, what is it? If this is false, it becomes true, I guess. Yeah, that's why I didn't implement this macro, because it is kind of confusing. I mean, sure, I can take the negation out, but yeah, I will just use the good old if statement. Okay, and then if not equal code expression, return alpha n. Function def, okay. Built in def pass incorrect type. Incorrect type. Yeah, I think later on we will have something like variatic function for the alpha R, I guess. Oh, right, we need to free the value. Okay. We need this one for the value. Don't forget this one. File line. Okay. And then we save the first argument as a symbol. Okay. What happens if we just passing the empty, what is it? Maybe something like this. Def 69. Yeah, what happens when we do this? Let's see. Struct for sims value cell 0. Okay. And sign in. Less than sims count. Maybe next time I will use the notation like this, but to make things consistent, I will use I++. I mean, if I understand correctly, in this case, did not really matter whether we use I++ or ++i, because we are using the side effect of this operation. But yeah, some people said that using ++i, what is it, does not require a temporary storage, something like that. I'm not really sure. Okay. Okay. We'll make sure that our element of the first list are symbol. First list are symbol. Okay. I mean, yeah, we are returning the error, right? Which means that I think, yeah, we deleted. Okay. Let me write that. If cell I type not equal, yeah, ++ I is back increment and I++ is post increment. If not equal, then we need to delete this first. Delete the argument. Right, deleting the value here. Okay. The value, and then returning this one. Like that, but this not really incorrect type. Cannot define. Right, maybe we should add this too. The empty list. Right. Maybe cannot. Okay. Cannot define non-symbol. Alright. Let me check here. Pass too many argument. I don't think. You know what? Why are we putting this in here and not at the top, And then we can just use sims, right? I have no idea. But first thing first. Wait, let me check in GTP. Break alpha. What is it called? No. Built-in head. Something like this. Run head 6942. Print value count 1. Cell. Okay, interesting. Put expression. Okay. Okay. Count 2. Num0. Let me check. Cannot access memory, okay. I mean, if we are doing this, value count to, we'll get an error, right? Any argument. So for this one, I think we need to at least have two lists, right? The first one is for the variable and the second one is for the, what is it called? The value. I mean, what happens if we do something like this? We are only defining the variable without any value. Well, let's handle that later on. And make sure this is working first. Take correct number of symbols and values. Okay. Correct number of symbols and values. All right. Okay, so we are checking that in here. All right. Seems gone. Yeah. Why didn't we check this first before checking this one? You know? Like, for example, like this one. If, what is it called? If the variable declaration doesn't have value, we can just return it immediately without the need to check if it is symbol or not, you know. Let's try that out. If, what is it again? Seems count not equal value count -1. Okay, so then we cannot just do this. Yeah, let's test it out later on and see how it goes. Deleting the value and then return. Bit and def. Cannot define. Cannot define. In correct number of symbols. Unequal, maybe. Unequal symbols and values. Maybe something like this. Count. After checking the count, let me put this in the bracket. Okay. After checking if the count is same or not, we check if it is a symbol or not, and then we put the symbol or variable, I guess, into the environment. Wait a minute. Seems okay for and guessing count equals plus okay, and we put what? Okay, that was interesting. env put env right. Okay, and then the symbol since I value, okay, we change this parameter name to value I plus 1. Okay, the offset. Wait a minute. I think we need to change this one because we already changed that to char pointer. Maybe something like this. Let me check. Okay, right. See, I changed this parameter because as far as I can see, we only use the sim field in here, so might as well using the sim type, which is the pointer to char. Okay, maybe something like this, and then value cell. Wait a minute. I plus 1. next time, gaming, welcome. Okay, something like this. And then we delete that. Yeah, I mean, I still have some concern about the symbol. Like, do we need to, what is it called? Do we need to create a spirit memory location for that? Where is it? We put yeah, let's check this out. I don't think we already done that in here, right? And then we're copying the symbol string into this one. Okay. And then we delete the value or free, I guess. Value something like this. Yeah, do we need to return this? Okay. Writing symbol in this pressing them to be defined. Explore what other complex methods are possible for the definition and evaluation of variable. Once we get to defining function, we'll really see some of the useful things done with this approach. Right, do we need to do this? I mean, if we do this, then well, we create another memory allocation. Let me sort that. This one. I mean, can we just like return null, something like that? I mean, what do we use with this return value? You know, and where we have this pointer, right? Let's try that out. I don't know. Or well, maybe we can also use return 0. But let's just use null. Okay. Alright, okay. Then mulai. Oh. The unused timeline, okay. Change of plan. Abort the mission. Not this one. Yes, okay. Git commit man, okay. Link message. Okay. And begini. Wait a minute. 70, okay. 72, okay. Alright. Oh. Wait. How can I forget that? Alright. X69 symbol does not exist. Okay, yep, I forgot again to initialize that. Built in init in this one. Def okay. Compiling. Alright. X69 second. Okay. Pre-alpha, or maybe put in dev, I guess, and run. Okay, dev 69. Okay, next. Alright. Next again. Okay. value count. Okay, next again. Since count. Next. I type for same. Okay. Next again. We're going back to the loop, I guess. And then next again. Okay, this is different looping. Wait, hold on a minute. No, not that one. I didn't realize that we have the same kind of condition, I guess. So yeah, why we didn't combine this? I mean, as far as I can see, it is the same, right? Yeah, maybe I should just combine this. Something like this. Okay, next again, and we put, okay, delete, return null, okay, alright, oh, wait a minute. 171. Return result. So if the result is null, and we are returning to null, where is it? No, not this one. This one, right? In the F file, we are returning null in the F file. Where is it? This one. So this F file is null, and we are trying to passing that to println. So this is something like this, I guess. And maybe that's causing the seg fault. Let's check that out. File F, okay, see. We are passing null to the println function. Next again, seg fault. Okay. We found the root cause. Yes. Compile again. Def x 69. Oh, sorry. I haven't run the program yet. Okay, and then X. Okay. Why is it success? Why is it success? Interesting. Yeah. This make me curious, like how can we check the symbol list in the environment? Like what happened with to find something like this? 69. Okay. Having unequal symbol and values. But yeah, that make me kind of curious. Let's try that out. Okay. Print values cell. Right. Okay, what is that? Okay, next. This is the code expression. Okay. Next again. Print sims count 0. Oh, okay. What about the value? 1. But yeah, because we doing this, right? It becomes 0. Did value count will become 0? Maybe not. Okay, next. I mean the symbol count is 0, so we should just pass this. Okay, deleting the value. Where is it? And then returning this one. Right. Oh. So we didn't put the, what is it called? The environment. Put the empty, what is it? Empty symbol, I guess. Okay. That is interesting. Rather than, I think, rather than making that as a success, right? This one, making this as a success, let's make that an error. Let's create an error message, I guess. Continue. Disable info break. Yep. This one. Okay, continue. And check this one. How about this one? Unequal symbol, okay? Yeah, we haven't handled this one yet. Okay, where is it? If sims count equals 0, right? Now we free the value and then we return until this. Yeah, I'm trying to use something like this maybe. Pass until this. Empty this. Wait, not that one. Scripts. But yeah, if I use this was incorrect type. Okay. Pass until this. If I just use def, yeah, this is the function. Def x y 6942 x y 42. Okay, what is the test that I should check? X and then y. Okay, just making sure. Okay, and then police. Oh, police. X, Y, Z, maybe. Police. Okay. Just gibberish. But that is not expected. I think. This doesn't right. PC XY this. Okay, so I don't think that is expected. Most likely because the copying stuff, I guess. See, sooner or later we find some problem. My assumption is that the problem is on, where is it? The problem is on, I think this one, the copy one, you know, like, where is it? Oh, this one. Okay. When the type is alpha sim, we just copy the value as is. And the problem is that the value that we have is from abstract syntax tree, the parser that we use, MPC. So when we already delete those value, those abstract syntax tree result in this one, right? What is it called? The memory address that we save in the environment become a dangling pointer. So we are kind of trying to access the memory address that already been free. And then, yeah, it is in the while loop. So we are looping again in the REPL, right? That is my assumption. Debug problem with this statement, or what is it, expression, I guess. There's Barclays XYZ. Problem might be related to when we are copying the symbol those XYZ symbol to the environment, but the symbols already deleted when we call, what is it called? STTL. So check LNV copy or LN file copy first. Okay. I guess that's it for now. Thank you for watching and see you next time. Bye bye.